College and today's broadcast of the North Idaho College Public Forum. The crew is comprised of North Idaho College television students. Your moderator is North Idaho College political scientist Tony Stewart.
Today is going to be our pleasure to discuss with you astronomy, and I think we'll be focusing mainly on planetary radio astronomy. In order to deal with this most interesting subject, it is a special privilege to invite to our program Dr. James W. Warwick. He is the president of Radio Physics Incorporated, located in Boulder, Colorado. As to background, he is the principal investigator of the Marina Jupiter-Saturn 1977 mission of the planetary radio astronomy experiment. Our guest has a very distinguished educational background, holding a baccalaureate, master's, and PhD degrees from Harvard University, receiving his doctorate in 1951. He is also a former assistant professor of astronomy at Wesley College and also a professor of astrogeophysics at the University of Colorado. He has been with us on our campus talking to our students about this very important field. I would also like at this time to acknowledge that our guest is from the Harlow Shapley Visiting Lecture Program of the American Astronomical Society. Dr. Warwick, welcome to our program.
Thank you, Tony.
Joining today in questioning our distinguished guest are three members of the panel. First of all is regular panelist Mary Lou Reed. Our second panel member is Mr. Kurt Nelson from our faculty at North Idaho College in Math and Computer Science, and Dr. Ken Wright, who's been with us many times, the panel member in the field of chemistry. We'll proceed to questions with Mary Lou Reed.
Dr. Warwick, as Tony has said, you were listed as principal investigator of the Mariner Jupiter-Saturn 1977 mission. Would you please remind us of the nature of that mission and then tell us what an investigator is? Sounds kind of like a James Bond enterprise.
Mickey Spillane is an investigator, isn't he? The mission has been renamed, I should say, to begin with. It used to be Mariner Jupiter-Saturn 1977. It's now the Voyager missions, which are going to the outer planets. These spacecraft were launched, two of them, in August and September of 1977, and they are en route now to Saturn. They have flown past Jupiter in 1979, Saturn in 1980 and 1981, on from Saturn to Uranus in 1986, and then from Uranus to Neptune in 1989. That may well be the record for space exploration, 4 planets with 1 spacecraft. My responsibility in the mission is for the design, construction, and operation, analysis of results from the radio astronomy experiments which are carried on each of these spacecraft. We've observed already gorgeous radio emissions from the planet Jupiter. We are now observing equally enigmatic emissions from the planet Saturn, which we will fly by on the 12th of November, just a few weeks from now.
What do you mean gorgeous?
We make these emissions into displays on paper.
These are sound.
These are radio emissions which are converted through electronic trickery into black and white images on paper, and they make patterns as the planet rotates that are diagnostic of conditions at the planet. And to my eye, which perhaps has been staring at these things so long that I'm misled somehow, but still, to my mind, to my eye, they are beautiful.
Thank you.
Kurt Nelson.
Yes, Dr. Warwick, the flyby has been in progress for some time, and you mentioned going on to Uranus and then outward. The flyby on November 12th, how long will that actually last? How long is it in process when you're taking data as you go by Saturn?
The spacecraft, of course, are operating all the time, year in and year out. The flyby technically begins at a point when the imaging, the television systems on the spacecraft can look at Saturn and get a view better than can be seen from the Earth. That began on the 22nd of August this year. So the flyby is several months long, simply because the television system is able within that period of time to improve on ground-based imaging of Saturn.
What are some of the things that are hoped to be looked at ring-wise? I notice there's, in the literature that we have received recently, there's usually new rings that show up, or even the finding of a new moon. What sort of things would you be looking for in that area?
This spacecraft is unique in the power that it brings in the form of this television system, which is really a telescope equipped with a electronic imaging camera at the focus. The telescope is so powerful that it may well be possible to see structure within the rings, the particles of the rings as they circulate around Saturn, and give a much better detail understanding of what the rings are composed of. That is one of the great mysteries of Saturn, what those rings are made of. Are the particles tiny, essentially the size of smoke or grains of sand, or are they bigger particles, perhaps up to the size of boulders, or even small cliffs and mountains? So that is perhaps one element of what we expect to learn better, what the rings are constructed of. I think that new rings are always a possibility. The same spacecraft observed or discovered rings at Jupiter, for example, that hadn't been known before March of 1979. But in addition to the fine detail that we will just see in the structure of the rings, it may well be that other experiments on board the spacecraft will observe gas in the vicinity of the rings, electrons, energetic particles, and the like, all together dealing with the rings. Saturn itself is a puzzling planet as much as anything, because it's almost impossible to see cloud details on Saturn other than simple zonal streaks, which are uniform all around Saturn. As Saturn turns, we see no variation in the streakiness of the planet. It would be very nice if we could see cloud structures such as Jupiter has that would provide understanding how the gases in Saturn's atmosphere rotate. And that's one thing I really expect to get out of this imaging system as well.
Dr. Wright.
Dr. Warwick, I want to ask a very general question. I'd like to get into some of the specifics if we have enough time, but of what value is the United States' program in the exploration of deep space, specifically the planetary exploration program? Other than satisfying scientific curiosity, what can we really expect to come away with?
If you take away the curiosity factor, you've taken away my principal answer, of course. The people climb mountains because they're there, I think it's said. We are curious. That's what separates us from most of the beasts, I would think, the depth and the continuity of our curiosity about things. And of course, we go into space because we can. We're capable of it technically, and because it's there, filled with a marvelous array of unknowns. The second important point that I resonate to in your question is, should we go into space as a very expensive enterprise? Billions of dollars are spent each year on the NASA program. Do we attain any benefit from that? My quick answer to that is that our space budget is a tiny fraction of the national budget, even though it's several billions of dollars per year. A third point that I want to make is that the space program, unlike many other enterprises that use up taxpayers' resources, uses these in a circulatory fashion. The money that goes into building a piece of space hardware essentially is money spent on brains, the salaries of engineers, rather than sending scrap iron across the Saigon jungles. We do not destroy our wealth when we build spacecraft. They are small, they are lightweight. The resource that we need for a spacecraft is embodied in our minds and our professional talents. But why should we do it? I think the fourth point that may be the most important to me, it has to do with the nature of science. Science today publishes more new results per year, let's say, than it ever has in history. Journals, professional journals in which technical results are produced in the open press, are multiplying exponentially. There are many more times as many technical journals today than there were even 20 years ago. What this means to me, if I may turn Malthus around, is that scientific research is nurtured and fed with an essentially infinite resource, which is the unknown features of the world around us. We know very little about the world around us. I would remind you of Newton's comment about picking up pebbles on the beach. And occasionally he reaches down and picks up an interesting pebble here or there. This is the man who, as much as anyone, founded modern science. He might have been egotistical when he said that, I don't know, but I think he was right, that the facts that remain to be discovered in the universe are overwhelmingly greater than the facts that we know about the universe. This teaches me that we should be very non-egotistical when we use our primitive understanding of the world around us to solve the problems that we face as people. Science is essentially open-ended. We have not reached our limit or even approximated our limit of understanding. I view the space program as approaching the unknown around us in a very direct, very intelligible way, and I regard that as essentially the future for us. The future for us is to know enough about the world to protect us from ourselves, and this is one way to get a handle on it, through the space program. Only one way.
For those who have joined our program in progress, our guest today is Dr. James W. Warwick, who is the president of Radio Physics Incorporated. He is also the principal investigator of the Mariner Jupiter-Saturn 1977 mission. We shall continue the questioning with Lou Reed.
Dr. Warwick, sometimes we do get mired down in the here and now, and one of these important here and nows are our national boundaries. How much international cooperation are you able to seek in this kind of a program? Is some of this information classified, or is there no way to classify information that deals with radio beams? And is there an international association? Could you expand on that?
Yeah, I would love to. The NASA programs have historically and are at the moment deeply involved in international science. I would regret only one thing, that Third World and Eastern world, that is to say beyond the Iron Curtain countries, are not involved in any deep sense. If we regard Europe as international, from our point of view, we are deeply involved with European science in the investigation of space. And that is totally a strengthening and resource that has been invaluable and will continue to be so.
Is there resentment on the part of third world countries against the space program because of the dollars that it takes, and perhaps they feel that they have more pressing needs for the concentration that space program takes?
I'm not aware of that. If there is a feeling of that sort, it's not something that has come into the orbits that I tend to inhabit. So I really can't answer competently.
Kurt Nelson.
Yes, I've heard some comments by some astronomers and doing some readings that Titan is one of the targets that we're trying to zero in on to look at Titan in greater detail. What are some of the expectations that you might find, knowing right now all the information that we know about Titan? What are the hopeful expectations that we might find there?
Titan is the largest of Saturn's satellites and one of the largest in the solar system. I think what you're referring to, Kurt, is the fact that for many years Titan has been known to have an atmosphere. It may well be an atmosphere containing methane, which hardly seems like a comfortable place to live. Methane or marsh gas is, of course, poisonous to you and me, but still, it's a small body relative to the planet around which it circulates, and it has an atmosphere, so that astronomers are interested as to why it has an atmosphere, the extent of the atmosphere. Is the atmosphere circulating? Do winds blow on Titan? What produced it? What is it composed of? Does it contain clouds and, for example, and lightning? It's even proposed that, I think by Carl Sagan, that Titan's atmosphere might contain lightning. And lightning, if you've been watching Cosmos on educational TV in recent weeks, is believed to be one possible source of the chemistry that produces life eventually. Lightning in an atmosphere of the sort that methane represents. So one of the things that Voyager will do, Voyager 1 on the 12th of November, will fly extremely close to Titan with only a few thousand kilometers of the surface of Titan, and will carry its array of instruments, its magnetometers, its energetic particle detectors, its spectrographs, its radio receivers, and its television systems so close to Titan that it may well be possible to answer some of these questions directly. For example, is Titan a possible source for life chemistry?
Dr. Warwick, we had a guest a couple of years ago, a professor of astronomy from the University of Washington, Seattle, and he was involved in attempting to receive signals from space, attempting to determine if there is life on other planets or in other galaxies and so forth, and he's very excited about that. In your work, are you involved in this or with some of your colleagues? What progress are we making in attempting to both send and receive signals from the universe?
Oh, I think that's a very exciting question, Tony. I would be interested to know which astronomer was it. Paul Hodge, perhaps?
Yeah.
Well, I think astronomers are excited as much as everyone about the possibilities of there being life, in particular intelligent life, in the universe other than our own. Of course, always one asks, are we intelligent life? And there's a question about that sometimes one feels, but still, there are so many stars and so many opportunities for planetary systems to form in the universe that we can't believe that the conditions have been right only in our own planetary system and only on the Earth. So I think the question is one that humanity wants to have answered, and astronomers are, of course, not only at the forefront of that in wanting to have it answered, but technically in a position where they may be able to do something about it. Now the question is how to do something about it. Over the years, I think it's clear, since 50 or 60 or 70 years ago, we've been sending out radio signals from this Earth. The signals that are radiated by television transmitters, for example, go off into space by and large. They are not received on our sets alone. They have to populate space, and whether those will be picked up and responded to by intelligent creatures on some other world, I don't know. The other side of the question, have we received signals, or can we receive signals from elsewhere in space, is of course answered affirmatively. We are receiving telemetry signals from the Voyagers right now, here today. The Voyagers are sending back information from 1 billion kilometers from the Earth. That's a long way, and yet it's only a tiny fraction of the distance to the nearest star. So the problem is one of ways and means. Can we receive signals from the nearest star? If the signals were transmitted in much the same way we transmit radio signals from television stations, the answer is that's very difficult. We need extremely large, extremely sophisticated radio telescopes to identify the kinds of signals that the Earth transmits at the distance of the stars, even the nearby stars. But I think we should be sanguine about this thing. We ought to be positive as to the opportunity is an important one, and that we can conceive of it doesn't mean we ought to do it, but that we can do it with limited resources seems to me clear, and there are a number of astronomers attempting this search, some obviously too primitively, others with more sophisticated equipment, and still others proposing large-scale programs to go after, well, to involve themselves in SETI, which is the search for extraterrestrial intelligence.
Dr. Wright.
Dr. Warwick, I want to give you a chance to put a little sales pitch on here, campaign just a bit.
It's that time of the year, isn't it?
Well, yes, it could be. The general public is being bombarded with quite a bit of information in the press now about the space program, because the Voyagers are on their way to Saturn, and in less than a month, the Voyager 1 will be there, and as you've already mentioned, they'll continue on. At least Voyager 2 is expected to continue on to Uranus and eventually on out to Neptune. And so up until 1986, we'll be getting some information hopefully back from those particular spacecraft. What the general public may not realize is that that those missions are the only ones that are right now current, underway. And the question is, you know, what should we be doing, if anything, as far as interplanetary exploration goes? And some of the proposals have been canceled by the administration, perhaps for good reason, perhaps not. But in your opinion, what do you think would be the most worthwhile missions we should be getting underway right now, so that when the Voyager mission is over, as it eventually will be, we'll have something else to be giving us some valuable information?
Yes. Many aspects of that question. Let me just tackle one of them. The follow-on mission to Voyager is called Galileo. And as you can imagine from the name, Galileo was the astronomer who discovered the satellites of Jupiter in early 1600s. Project Galileo involves sending a spacecraft to Jupiter. In fact, now it involves 2 spacecraft on separate launches. One spacecraft will orbit Jupiter in a beautiful petal-shaped orbit that will investigate the entire satellite system in a very systematic, comprehensive way. The other spacecraft will probe the atmosphere of Jupiter directly, will enter the atmosphere and measure in situ the chemistry, the fields, the light, the cloud particles, etc. in the atmosphere. That mission has been postponed as a result of problems with the space shuttle, which I think are common knowledge. One wonders, in the sequence of postponements, at what time does the postponement become permanent? And I am nervous about it for the reasons that you hinted at. How long will the public will to support a mission that's being postponed continue? I think it's an important mission to give us the insight into the structure of the Jupiter system, which was only probed in a very provisional, offhand way, if you will, by the two pioneers and the two Voyagers which have flown past Jupiter. Let me put it this way. A single spacecraft flying past Jupiter occupies itself with Jupiter for only a few weeks, or at the most a few months in the case of the Voyagers. Jupiter is a dynamic planet that changes in its appearance, as known to be the case from ground-based observations over decades and centuries. You can't expect to learn even more than a few snapshots of Jupiter when you fly past it in a few weeks or a few months. The Galileo program takes a long and patient look at Jupiter and hopefully will give us the kind of insight into the dynamics of the Jupiter system that we can only guess at on the basis of what we've seen so far from 4 spacecraft flybys.
Lou Reed, we have about 2 minutes.
Dr. Warwick, in those remaining 2 minutes, could you give us a little list of the qualities that you feel make up an astronomer? You've mentioned curiosity. Obviously, there has to be a certain amount of patience. If you start a party in 1977 that isn't going to be done until 1989, what kind of breed are you people?
I would
Very
like
pleasant, in addition to pleasant.
Thank you. I would like to be the breed of person that you can see. You know, here I am, an astronomer, to be touched and talked to, a person, first of all, a human being. An astronomer, most astronomers that I know became involved in astronomy when they were little people. I was, I think, perhaps 8 or 9 years old when I got involved in astronomy first. It was this curiosity business, I suppose. I went out one night and looked up. Maybe I had looked up before, but this time when I looked up, I saw stars. And I have wondered about them ever since. I think that quality of wondering what things are may be the most important thing for an astronomer or any other scientist, so far as that's concerned.
I wish we could continue, but we're out of time. I'm so sorry. Thank you for being with us. It's been a great pleasure.
You're welcome, Tony.
Ladies and gentlemen, our guest has been Dr. James W. Warwick, who is the president of Radio Physics Incorporated. We have been discussing astronomy, and I hope you've enjoyed our program. And please be with us again next week. I am Tony Stewart.
The North Idaho College Public Forum can be seen at this same time each week over this station. This production was videotaped earlier by a North Idaho College student crew for viewing at this more appropriate time.